Hi all. So today's topic is on loops. So let me just write the heading as loops. Okay. So what is loops now? So let's say you have a bunch of code written here like this. Okay, and these 3 to 4 lines, these are same thing. Like let's say these are all printing something south, 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 and south. If you see, they are performing the same type of action. However, there may be some changes in the print, the command inside this. Okay, here it may print 2, here it may print it as 3, here it may print it as 4. But in general, what it is doing, it is just performing the same action, right? So whenever we have some sort of codes which are repeating continuously, so instead of writing it in a separate line every time, what we can do is we can just compact this and convert it into a loop. So what this will do is just with the help of few lines, we can convert this, like we can run this sort of code for multiple times. Okay. For example, now if I give you a simple task to print first 10 numbers, okay, without the knowledge of loops, how would you do it? You would have simply done it like south, south 1, south 2, so on up to south 10. So if you see, we have 10 lines of code now. Okay, but if you use the loop, this instead of having the 10 lines of code, we can just complete it with just 2 to 3 lines of code. Okay, yep. So what does loops do? Loops help us to write the optimized code. Okay, with the help of loop, we can write the optimized code. Now, then in loop, what are the types? So there are two types of loops. One is while loop, okay, and the other one is the for. In while loop, again, there is like while and do while, but we'll not go in that technical. Like it's not that difference also. We'll just see it in a while. So coming to while loop, you can consider while loop as similar to your if condition. So if you remember in last class, we discussed about if condition. So how will the if work? So if will work like based on this condition. If this condition is there, then whatever is there inside this block, it will run. Okay, how many times? It will run for just one. When it will run? When this condition is true. Similarly, how while loop will work? You have to say while, and then you have to specify the condition, and then the bunch of code. But here, the difference here is that here it will keep on running until this condition is true. Okay, so here it will keep on running like by default, I'm giving it as infinity. But until this condition is true, what will happen? This code, whatever you have mentioned here, will keep on repeating. Clear? So let's try to have like a simple this. So we'll try to print first 10 numbers with the help of while loop. Okay, so let me just take the first thing. So here what I can say is, let's say int. For that, I'm going to say num equal to, initially we'll start with, let's say 1 colon, and here I'm giving while I'm giving the condition while my num is less than, let's say 10, less than or equal to, I can say equal to 10. And as I said, we need to give the parenthesis. So this is what a condition now. So until this condition is true, it will go on inside this curly brackets. So here what I'm doing south, and I'm printing num. Okay, and if I run it, okay, if you see the output, okay, now, so what we got an error, not an error in sense, like here what happened, our loop is running for infinite times. If you see, it's still running. Like if I just scroll down, the loop has not stopped yet. And if you ask me like why this has happened, this is because, let's try to analyze what happened here. Where is the marker? Okay. So you said your num is 1. After that, you compared here. 1 less than 10. Yes, it is true. Then it went inside this condition and it printed the num. After printing the num, as it is a loop statement, so it goes back up here and again it checks the condition. Now num is what? Num is still 1. We didn't update or do anything. So this condition is still true. And again it goes down and it will print it. Then again it goes up, checks it, true, run, repeat. So if you see, it keeps on repeating. Okay, so whenever you are using a while loop, you have to take a care that you are stopping your loop. Like you are writing a condition where this loop will be false. Like you are not giving any universal conditions here. Like what would be the universal condition? Like always by default saying it as true. This is something like a universal condition. Then again, second thing you can something like say like 2 less than 3. This is universal. This is never going to change. So if you give something like this, then your loop is always in infinite. Clear? Now, to stop this loop or to make this loop work properly, what I'll update is that I'll just update my num so that there will be a one point where num will be equal to 10. And once it is equal to 10 or greater than 10, then our loop will stop. And for this, I'm using the which operator? Arithmetic operator. Inside that, I'm using the unary operator, that is num plus plus. Okay, and if you see, I got an error. Okay, I'm sorry, I didn't give the semicolon. And if I run it, okay, if you see the output, what it is doing, it is printing 1, 2, 3, 4, 5, 6, and up to 10. So what happened here? By this time, it just printed up to 10 because every time when it goes inside this block, after printing the number, the num is also being updated. So here it is 2. So next time when it goes to check the condition, here it is checking 2 less than 10. Yes, it is less. Then it goes back inside this. It prints the number, that is 2. Then it updates back. Now 2 is now the num is what? 3. Then check once again. 3 is less than 10. Yes. Repeat. Update it. Repeat. So it keeps on happening until the value is reached 10. So once it is reached 10, so it goes back here. Now 10 is equal to 10. Great. It will like print the 10 once. And after printing the 10, what will happen? Num plus plus. Once you do num plus plus here for 10, the value of num now will be 11. Okay, once it is 11, when you go to check the while condition, 11 is greater than 10. So this condition is not being true. Okay, so as this condition gets false, then the while loop just stops here. Okay, clear? Okay, good. So I hope you have got it. You have got the while loop, how it's working, right? Now let's understand how the for loop works. Okay, so for loop, it's a bit similar, but here there is a quite difference. So while loop is like based on conditional base, we can say conditional based, whereas for loop is iteration based, we can say iteration based. That means in for loop, we somewhat have a rough idea like how many times we are going to run our loop. Whereas in while loop, we do not have that idea. We just have the idea that until this condition is running, okay, like until this condition is true, this while loop will run. Now, what will be the syntax for loop? The syntax for loop is something like this. So for, first you initialize, okay, you initialize the variable, okay, then you check it. You check is nothing but here you can also say it as you give the like condition. Okay, then after that, what you do, you update it. Okay, what you update, whatever you have initialized it. And then inside this curly brackets, whatever you mentioned, it will keep on running until this condition is being met. Okay, so how so let's try to write the same what we printed 10, right? 1 to 10 numbers, 1 to 10. We'll try to run the same code with the help of for. Yeah. So for that, let me first clear the screen. I don't want this, and okay, this much I'll clear it, and now I'll just write it. So what I'll do, I'll comment this part as this is not needed. And then here I'm going to write for, let's say I'm saying n x equal to, first I'm initializing, right? So I'm saying x equal to 0. Then I'm saying x less than what we want. Here what we are again, less than 10, less than or equal to 10. So I'm copying the same condition here. Okay. And then what I'm giving here, x plus plus. So if you see, I have written whatever you have written here while loop in 3 separate ways. Like here it was initialized, here it was the condition was checked, and here it was updated, right? That all the 3 steps I have done in single line. And then I wrote a curly brackets. And inside this, what I'm doing south x. Clear? And I actually do not require this num variable also. So I'll comment it. And if I run it, so if you see the output, 1 to 10 has been displayed. We started with 0. So if we start with 1, then it will be from 1 to 10. So if you see, it started with 1 and went up to the number 10. Clear? So the syntax is bit like similar. Like if you see, there is not that rocket science here. We are just having a conditional initialization phase. Then we are checking the condition and we are then updating it. Okay, like if you want to dry run it once, let me dry run it. Dry run is like nothing but we are checking it without the running this. So let me remove this part. And now let's try to see how it has worked. So first you said x equal to 1. Okay. Then you compared here. Okay. Now x is less. So this will be 2. Then what will happen after this? It goes down to this statement. Okay. Then it was doing print x. So it will print x. After that, the initialization phase will never be executed. It is just executed at first. Then it goes back up. It updates. The value is updated as, let's say now 2. Then it again checks the condition, that is x less than 2. Yes, it is. This condition is still 2. So you say 2. Then it executes this system out dot println. So this is printed. That is 2. Then again it goes back up. It checks x plus plus, like it updates the value. Now the x value is 3. Is 3 less than 10? Yes. Then what it will do? System out println x. So here 3 is being printed. So it keeps on happening like this until it reaches 10. So once it prints 10 here, it goes back up and now the value is 11. So it will try to check this condition. This condition is false. Okay, because 11 is greater than 10. Therefore, it doesn't come, it doesn't go inside this condition and it will come from here. It jumps out of this bracket. Yeah. Okay. So I hope you have understood the concept here, how the loops are working. Let's try to solve a few problems. Okay. And let's see how while condition is actually used, where the while condition is actually used. For that, what I'll do, I'll take, let's say I'll store a password. Let's have a hypothetical situation that we are creating a website and we are creating a username and password field. Okay. And we are asking for the user to enter the password. So if he enters the wrong password, we are giving him chance to re-enter the password continuously. Okay, so I'm creating a variable and I'm storing it as by default password as 1234. Okay, I'm storing it in string. So I have to make it string data, string. Okay, so once I have done with this, now what I'll do, I'll say, I'll ask for the input. So I'll ask for the input, then again, the input should be in string. Then answer from the user equal to, I want input. So for the input, now what I'll do, I'll take the scanner class, scanner sc, or you can do input, whatever you see, equal to, it's a variable name, new, I'm creating a new instance of scanner. In that, I'm writing system dot in. Okay, I'm removing the unwanted this and code. Okay, so what I did, I just created an object. This all will be discussed in our future classes and all once we reach the oops concept. So I'll make sure you have this statement here. Okay. Now, after proceeding in next line, what will happen? Now I have to take the input. So we have discussed to take the input, what we say input dot, which type of data it is, string. So I have to say next. Okay, even if I say just next, it's fine. And then colon. Okay. Now here I'll check that while loop I have to put. So I'll put while. I'll say answer dot equals. So there is a function said equals what? Equals password, right? Password. So do I have to compare it like when should this loop run? When it is not equal, right? So we had learned a logical operator named as not, right? Which is nothing but a straight line like this. Where is my this? So we had learned an operator as not. Okay, so this is nothing but not equal to. So when our answer is not equal to password, that time we'll ask for once again to re-enter the password. So I'll say this, I'll put inside. And now whatever I have written here, I'm just going to copy and paste it here in the same line so that I'm again displaying the asking the user as for the new password. And I'll just do a south so that user understands. Enter valid PWD. Okay, so once the while loop, like if the while loop comes over from this, then here he'll get a message saying that south logged in. Log in. Otherwise, he'll be kept on stuck in this loop. Okay, so let's check it. So I'll run it. So enter password. So I'll enter anything random thing, any text. So if you see, it will make us stuck in this loop. So until I enter 1, 2, 3, 4, that is the correct password. We are stuck in that loop. Now, as I enter 1, 2, 3, 4, the condition here got correct. That is it is equals, and the not like is opposite of that, and therefore this entire thing just got skipped, and we came to this part that is logged in. Yeah. Okay. Now this is where like you use the while condition. So if you see here, like using the while loop made much more sense because this was a conditional based. Okay. Now let's try to slightly update it. So if you see what I'm doing, I'm doing this answer like I'm asking this input dot next here, as well as I'm asking it in 19th line also. So instead of asking it for 2 times here, I'm just going to initialize it at once. So I'm initializing it as string answer. And here, I'll just remove this while condition from here, Control X. I'm just going to say do. And then at last here, I'm going to paste that while condition and the line with colon, semicolon. Okay, so if you see now what happens is that we are using the do while. Okay, that is nothing but the updated version of the while. Like when do we use this do while? Whenever we want to perform some action. So the first action should be taken itself, and from the next action, that is from the second action, we have to check if it is true or false. Like we have to check the condition. Okay, so here what was the first step that was necessary? The first step was to take the what is this input, right? So instead of saying it here, I just involved that like in single line here itself. So first it will do it, no matter it is true or false, like this condition is true or false. It will run it once. After that, here it is going to check the condition. Okay, so if it is not equal to, then it will go back here and it will keep on stuck in this loop. It will keep on asking until both the answer are equal. Okay, so let's check it. So I'll just run it. And here enter valid password. Let me enter something random. Close this random. Let's see. It doesn't work. If I enter anything, it doesn't work. So it will just stop when I enter 1, 2, 3, 4. Yeah. Okay. So this was the syntax for do while. Just make sure when you write do while at the end, there is a semicolon. Yeah. So let's see what all we have discussed. We had discussed like while loop. Yeah. Then we discussed a for loop. Then later we also saw how to use the do while. Okay, when to actually use do while. Yeah. Now, once we are done with this much, let's try to solve few problems. So the problem statement is to reverse a given number. So let's assume we have a number like 1, 2, 3, 4, 5. So what we have to do is we have to reverse it to 5, 4, 3, 2, 1. Okay. So now, how will we do this? So first of all, what we want is let's focus part by part. Like from this number, let's try to focus on getting that is the first digit, that is 5. So how would we get it? So there is a logic for that. So if we divide this 1, 2, 3, 4, 5 by 10, then what will happen is 10, 1, 2, 3, 4 is nothing but 1, 2, 3, 4, 0. And at last, we'll get the remainder as 5. So what did we understood that? So whenever we divide a number by 10, the remainder will get its last digit. Okay, so the remainder will get is its last digit. So that is nothing but like 1, 2, 3, 4, 5 modulus of 10. Okay, so this will give us what? Last digit. Okay, so now we got last digit, that is 5, but now the next task is to get 4. So the whatever the logic we have used here, so the same logic will keep on repeating. Is here we have to just use 1, 2, 3, 4 divided by like 10. So this is 123. This will be 1230, and we'll get the 4 as the remainder. Okay, if you see, we are just repeating the logic, and we'll keep on getting 5, 4, 3, 2, and 1. Okay, but now there is one more thing, is how to get this part 1, 2, 3, 4. So if you observe, this number is same as this number. Okay, so this you can simply get it by saying whatever is our original number 1, 2, 3, 4, 5 divided by 10. If you do it, you will get this original number. Okay, so let's try to put this everything in logic. So what we'll have this as a formula. We can say our reverse number. Initially, we can say our reverse number is equal to 0. Okay, and here we'll say our reverse number, we are nothing but updating it, reverse into 10. Okay, plus last digit. Now, initially starting at least it is reverse into 10 is like this is 0. So last digit is what? What we are getting the first last digit, that is 5. So we'll have it as 5. 5 is what? A reverse number. Now, after this, again, the loop will run, and now the this will be 5 into 10. This will be 50. Plus, what is our last digit now? 4. In our next loop, that is 50 plus 4, we'll be having 54 as our reverse number. Then again, the loop is going to run, and now our reverse will be 54 into 10, that is 540, plus the last digit now is 3. So we have 5403, so we got 543. So in the same way, it keeps on repeating, and at last we are going to get the value as 54321. Clear? So let's try to put this in a code. So what I'll do, I'll just go and type here. So first of all, what all variables I require? I first require a variable, let's say int num, which is having the value as 1, 2, 3, 4, 5, or I can just say 1, 2, 3, 4. I'll end it here. Then I require one variable for last digit. Initially, there is nothing in this last digit. Then what else I want? I want one more variable whose it's reverse, and for starting we are saying it is 0. Okay. Then what we'll do, we'll go inside a loop. I'll clear this. Okay, I'll say while my num, whatever is my num is less than is greater than 0, then keep on coming inside this loop. Why greater than 0? Because we are going to keep on dividing this num to get the sub values like 1, 2, 3, 4. From that we have to get 1, 2, 3. Then from that we have to get 1, 2. So for that purpose, I gave it this condition. And inside this condition here, I'm saying I'm first calculating my last digit. So last digit equal to whatever is my num. Okay. So for that, modulus of 10 I'm doing. So that value will be stored in last digit. So for starting, it is 4. So 4 will be stored here. And then I'm writing the formula for reverse. Reverse equal to whatever is my reverse into 10. Okay, so we just get the 10th digit. Then plus. So initially 0 into 10 is nothing but 0. Next time it will be 4 into 10, 40. And then we have to add the last digit, whatever it will be, plus last digit. Okay, and the colon. And at last, we also have to make sure our num is being updated. Otherwise, this will be an infinite loop. So I'll also do num divide equal to 10. Okay, I just wrote it in short and I said 4. Okay, so once this loop is completed, and if I print south here, and if I do my what is the reverse? REV. Okay, if I just Control C and Control V here. So you should be seeing is instead of 1, 2, 3, 4, now it should be 4, 3, 2, 1 in the output. So if I run it, so if you see the output, it is displayed as 4, 3, 2. It's not with just this number, you can use any number. 6548. I just randomly typed it. And you see it is 8456. So basically what we have to do here in this problem is that, so user will give us any one number, okay, and we have to check if the number is prime or not. What is prime? A number which has a factor of 1 and the number itself, that is n. For example, let's take 7. 7 has like only the factor 1 and the 7 itself. Okay, 11. 11 has the factor of 1. Okay, and the number itself, that is 11. Yeah. So now, how would we do that? There are actually 3 ways. Okay, so first way, this is the beginner, I can say. Second is intermediate. Third one is something pro. So if you see, like what we like, when will we say that a number is prime? So for example, if we take 100 and if we start from 2 to 99, and if we find any number that is like that divides the 100, then we will say it is not a prime number. Okay, if we don't find any number that divides the 100, then we will say it is a prime. Okay, clear? So we have just ignored the first one as well as the last one, that is 100. Okay, so we are running our loop from 2 to 99. Why? Because we know 1 and the number itself, n, will be the factor of itself. Okay, so here you have to basically check for here you will be using the for loop to go from this point to this point, and whenever you are going from one point to other point, you are simply checking like 100 modulus of x equal to 0. If this condition is true, then you will just stop your loop, because even if you find one factor, the number is not prime. So first let's try to code this part what we have written here. Here I'll just first create a variable. So int num equal to, let's say any number 1, 2, 3. Okay, now what I'll say is for this is Java, right? So for I have to say int x, I'm initializing it as equal to 0. Then I'm saying colon x, I'm saying until less than num. Yeah, so I didn't say equal to because I don't want to take the 100th number. I just want to compare up to 99. And then I'm also updating, like doing x plus plus, so that my x is being updated. And in this, I'm giving the if condition. If what should I give? My num. If there is anything like Control C, num modulus of x is equal to 0. So if this condition gets true, Control C, condition gets true, then what I'll do is I'll say south not a prime number. Clear? Okay. Then if this condition, and once we get the prime number, then it's not necessary to check for another prime number, just one prime number, sorry, if we get one factor, it's not necessary to check another factor. Okay, so any fact, like a number having more than 2 factors is considered as a not prime number. Yeah. So, but the condition here is that the problem here is that how would you write prime? So for a not a prime, you wrote like this, but how would you write a prime? So in case if you thought to write it like this, else prime, this will actually be a slight bug in this. If I do prime, what will happen is that it will keep on repeating prime. So let's do it for small number. For example, let's do it for just 12. Or let's do it 11. We check first. Let me clear this screen and let me run it. Okay, so the error here, it is giving that arithmetic expression by 0. So while explaining, I said we have to start it with 2, but I gave it as 0. So it should actually be started with 2. And now if I run it, okay. So if you see here, the prime is being displayed continuously, and which we don't do. So to avoid this, what I'll say is I'll create a variable. Let's say the variable is Boolean type, Boolean, and I'll say is prime, and is this initially I'll say it is true always. Okay, but whenever this condition is met, what I'm going to say, I am going to convert this as false, is prime equal to false. Okay, now once I have this condition, so I don't require this if, I'll just come outside the for loop. Okay, and here I'll write if is prime. Okay, and now I can just say like this, is prime, and here I'll give a bracket. So is prime means it is true, so I'll simply say south prime number. Okay, here I can just update this line once more, not a prime number, as it is divisible by, it is divisible by. Okay, and here I am adding plus what is the value I have to add? X, because at that moment it is divided by X. Okay, and here I have forgot to give this semicolon. And okay, it looks good. Let's check it. So if you see prime number for what? 11. Let me update this number to something 1, 2, 12. And if you see, it is not a prime number as it is divisible by 12. Let me do 15. So for this, it should give 3. So if you see, not a prime number as it is divisible by 3. Clear? Okay. So as we like at the starting, we discussed there are 3 ways. So we just now what we did is the first way. The second way is the updated version of this. So if you see here, how many times our loop is actually running? So our loop is starting from 2 and it is going up to n minus 1. Okay, in case if it is 100, it is going to run up to 99. Clear? But if you know, there is a bit logic here. That is, a number, take any number, for example, 100 itself, the maximum factor of this is half of it. That is 50. Okay, there is no factor greater than 50 that is divisible, like that will divide 100. Okay, for example, you take any number. 4. 4's maximum this is 2. Okay. Did you get it? Like what I'm trying to explain here? Because like if let me draw the time frame. If this is starting from 1 to like 100, so this is here 50. So it's like all the factors are present here in this range, and there is no factor present in this range. Because let's say even if you take the next factor 51. And if you try to multiply it just next number, like 1, it will give 51 itself. But if we do it with 2, it is going to give us 102. Okay, so no factors are present here. Okay, because this will give the number greater than 100. So the maximum number is 50 itself. So once we realize that all the factors lie in this range, then we can, it also makes sense that we have to run our loop only in this thing. Okay, so the time taken for running in this loop is just saved. Okay, so to update this, what I'll do here is, here I'll simply say whatever is my num, I'll say num divided by 2. And if I run it now, see, so it is working smoothly. So let me check for higher number, let's say 101. This should give us prime. So if you see, it is a prime number. In case if I do it 2 and run it, so you see not a prime number as it is divisible by 2. Clear? So here what happened? How many times the loop is running here? So here if it is running for let's say 98 times, here how many times it is running in the first way? Here it is running for 98 times. 98 times because we are starting from like 2. 1 is skipped here. And here 100 is skipped, like that is skipped. So here we are running for 98 times. Yep. And here how many times we will run is half of it, like whatever is our n. It's half times we are going to run the loop here. Clear? Okay, but there is still more an updated version of this, like I can say the pro version of this to solve the problem. So if you see how it's that possible, so let me, for that, I'll just write the factors of this. So for example, let's consider 100 itself, as it is a large number and good number. So the factor of this are 2 into 50. Then I'll say 4 into 25. Then I'll say 5 into 20. And at last, I have 10 into 10. So if you see here, the number is going on increasing, and here the number is going on decreasing. So no matter, like, after any number, if I took after this, that is the number which will come here is 20. Now here the number should be what? Decrease. So here it will be now 5. Here if I took what? 25. Here it will be what? 4. And here if I took 50, here it will be what? 2. So if you try to see there, here you can see a pattern. That is, the number are being repeated. That is the first thing. And if you see, after the greatest number, like the 10, here whatever you see, this 2, 4, 5, these are again repeating here itself, 5, 4, 2. Okay, so it doesn't make sense to like again check after this line. So if we just check up to root n, what is root n? So if 100, this is 100, 100 is n. So root n of this is nothing but 10. Okay, so if we just run our loop till root n, so we are just going to check from 2 to this. Okay, and if there is any factor present here, that means it's not a prime. And if there is a factor present here, then, if there is no factor present here, then it is a prime number. And as we can see here there are how many factors? 1, 2, 3, and the 10 itself, 4 factors. So this is 100 is not a prime number. Okay, so I hope this part, whatever I have explained right now, is clear. If not, just rewatch it once again and it will be a bit clear. Okay, so let's try to code it. So if you see, okay, let me undo first thing. So if you see here, how many times we have to run our loop? We have to run our loop up to root n. Okay, and root n should be included because here root n is what? 10, and we are including 10 also. So for that purpose, what I'll say, I'll update my code here saying num, and I'll do maths dot square root. Okay, first of all, let me import the maths. Oh, it is already, I have this statement, so I can say maths dot square root is square root, and inside this I have to give num. Okay, and I'll give here equal to also because I want 10 to be included in the loop. Okay, so once I do this, let me clear the screen, and if I run it now, so not a prime, okay, not a prime as it is divisible by 2. Okay, and if I do it 100, let me check, it will still give me the same, not a prime number. Let me do it for 101 and run it. So if you see here, it is displaying as prime number. Okay, so it works for all the numbers. So if I make it 11 also and run it, it should give us prime number. Clear? So we just discussed 3 ways to do it. Okay, and let's visualize it, how the 3 ways are important. So the first way took us how much? Let's say if we are starting from 1, it took us up to n minus 2 times the loop is going to run. Okay, whereas in the second way, how many times it is going to run? It is going to run by n by 2, we can say. Clear? Because we just realized there is no factor present in this range, so no need to run this. Then after that, we again realized that the factors are keep on repeating. So we just made sure that whatever is our n, its highest factor is nothing but root of n into root of n. So if this decrease, this will be increasing, that we just saw. So here in the third problem, what we discussed, we just ran our loop up to root n. Clear? Okay. So I hope you have understood this prime problem. So that's it with for loop classes. And in next class, we'll come up with some new problems. Bye.